Okay, this is our next topic. So probability generating functions. You'll see why they're useful as we go through. So I need to kind of explain them to you first, then we can start actually doing some stuff with them. So they're functions which summarise a probability distribution. So up until now, your probability distributions have been given as a table, and it's turning that table into a function. And you use for discrete distributions which take non-negative integer values. So the values that your discrete random variable x can take will be non-negative integers, so 0 upwards. Doesn't have to take all of them. So if we consider a discrete random variable x, this is a definition for a probability generating function of x. So g, and we use lowercase x there, t is equal to the sum of t to the x, oops, sorry, I was meant to be an x, or 2, t to the x times by the probability that x equals x, which probably looks a bit odd at the moment. And t is what is called a dummy variable. This will make more sense once we do an example. So t is a dummy variable. It actually just becomes a place value, really. But I'll explain that as we go. But we haven't seen one of those before. And this is notation for the probability generating I wonder whether it should be lowercase or capital X now, sorry. I'll have a look at something. Function of x. Let me just check. Oh no, it is, sorry, it is capital X in there. Lowercase x there though. Sorry. Right, so that's your definition, and I'll go for an example. So e.g. x, probability x equals x. So x in this instance is going to take the value 0, 1, 2, 3, and it's a probability distribution. So this is how you're used to them looking. It's like that. All the probabilities add to 1, and then the probability generating function of x is the sum of t to the power x times by the probability that x equals x. So you start with your smallest value, which would be x equals 0. So it would be t to the power 0 times by the probability that x equals 0. T to the power 0 is 1. Probability x equals 0 is 0.2. Then we let x equal 1. T to the power 1 is t. The probability x equals 1 is 0.6. And then you let x equal 2. So I've now got 0.1 t squared in there. And then I let x equals 3. Probability x equals 3, 0.1 times t cubed. And so that is the probability generating function for x. And you can go from there back to there by looking at your powers of t. So t is a dummy variable. We're not actually substituting anything into it. All it is telling you what the value of x is here, 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 here. So here the value of x is 3, here it's 2, here it's 1, here it's 0. Couple of things to note. I'm not getting new board because I seem to be getting big writing. Just to remind you about expectation. So we did a bit of this recently. So the expectation of x is the sum of x times the probability x equals x. So going back to there, you would just do times, add, times, add, times, add, times. If you wanted to find the expectation of x squared, you would do the sum of x squared times the probability that x equals x. So you square your x times by the probability, square your x times by the probability, and so on. And then we can extend that a little bit. If you wanted the expectation of t to the power of x, that's going to equal the sum of t to the x times the probability x equals x. So that is exactly the same as our definition for the probability generating function of x. So just as a note, because I think we'll come back to it at some point. So the first note is that this is also equal to the expectation of t to the x overthinking this. Let's put some capitals in for those x's there. Sorry, I'm so pernickety, so it doesn't really matter, but I think capitals would be better. And then the other thing to note is when t equals 1, if you do gx of 1, so I'm letting t equals 1, then you get the sum of 1 to the power x times the probability that x equals x. 1 to any power is just going to give us 1. So that's equal to the sum of the probability that x equals x. And if you add all your probabilities up, you get 1. And so if you replace t with 1 in the probability generating function for x, you will get 1. So it's just a couple of little results to be aware of there. This second one, if you look at it in context here, so if you let t equal 1, you get 0.2 plus 0.6 plus 0.1 plus 0.1, which is 1. So it's just like adding those together.